What is the health of our soil? And why is it important to know the health of our soil? How is it even remotely connected to us? Well, join me in listening to Jeff Goebel, who is going to explain very well how we are all connected in this planet. Hello, I am Rajitha Bommakanti, registered nurse, faith-based holistic coach, and founder of Healthy You Lifestyle Center. If you want to develop healthy habits for life, one step at a time, click the red subscribe button and the bell icon now. What is the health of our soil? Why are we so concerned about it? Well, where does our food grow? Where does it come from? And also the soil pollution, the air pollution, water pollution, how are they all connected? And how is that really connected to humans and the human health? Jeff Goebel has very helpful displays in explaining to us about the whole connection and how it's connected to our health and well-being. Jeff, it helps small farmers in New Mexico area with eco-restoration and regenerative agriculture. Join my conversation with Jeff.
Hello, Jeff. Welcome.
Good. Hello. How are you doing today?
Good. Thank you. Thank you for joining us today. I wanted to ask you, as you have been doing wonderful work in educating people about the earth and the unconscious harm that we do on a day-to-day basis. How did you get interested in educating people around about the earth and the harm that we are doing to the earth?
Yeah. Well, going way back, my father, I guess, probably had an influence on me in terms of he was a natural resource person. And as I've learned more about ecology with him, and then through my professional career, I started realizing the challenges we were having with our ecology. And then as I've learned more, I have learned how this affects all of us. All of us are connected in this situation. And so I'm very passionate about sharing ideas. I think what I'd like to start with is to share a little bit of a PowerPoint presentation and some of these ideas, these concepts. And the first one starts with this nature of human health and the soil, the connection between the two. And so what's really interesting is that since 1940 to 1991, when the study was done, that there's been this huge depletion of minerals in our vegetables, okay, in the food that we eat. And so like copper's declined by 76%, calcium's declined by 46%, iron's declined by 27%, magnesium's 24, potassium 16%. And what's interesting is our health as human beings starts with the food that we eat, the quality of food that we eat. So there's been this drastic decline that's happened over the years. And so basically it says that by going by this, you would need to eat twice as much meat, 3 times as much fruit, and 4 to 5 times as many vegetables to get the same amount of minerals as available in the same foods in 1940.
Wow.
So that's really interesting. Yeah, it's very interesting. And so going to sort of the story about it, why that is, this visual right here is sort of denotes the web of life, that how everything is connected to each other. And so there's nothing that's really on Earth that's in isolation. It's all connected in one way or the other. And as we advance, this is a kind of a concept of what I call succession. And so you can have bare ground on land, like if we're on the eastern coastal areas, when you bare the soil, like if you go out there with a bulldozer or or fire or something like that, there are certain species that live in this area when it's bare ground or a bare field. And then quickly it starts to start populating with what we might call weeds or grasses and things like that. And then it gets to another stage where there's more shrubs coming in, and then there's a forest that comes in, and then later there's an old growth forest, or like a, you know, quite a diverse mix of species, and it's quite different. The structure's changed from where it's the forest from where it was bare ground. And what's also interesting, so does the birds. You know, there's different types of birds that live in each of these things. Okay.
So
And
quickly going back to that slide, Jeff.
mhm,
So when there is bare ground, so you need those other species to be coming in to cultivate that area for all this growth to happen.
perfect. Exactly. Exactly. So it's stages. It happens
Okay.
in stages, and it happens the other way in stages. And
Okay.
so, um, so it's important to understand this concept that things are what I call successional. That you
What
won't
you
find,
just showed in the previous life, we are all like a web of life together. We need every single one of these, on our planet
yes, yes,
to grow, have a healthy life for each and every creature on this planet.
exactly,
Okay.
exactly. And the interesting thing is that this previous picture here is one slice of where that, like, this is in the savannah. These are the species you would find in the savannah of Africa, and that would be like this area right here. This middle area would be the savannah type lands, and you would have a slice of all those different species on that previous slide in that one area right there. Now, as you go backwards or you go forwards, the mix kind of changes, and so the next picture here just sort of shows that um, it's got a lot of verbiage on here, but again, it's the same idea that you're getting the successional shift from low succession to high succession. And down here, you see it says birds, mammals, insects, reptiles, microorganisms. In the communities, they have various ranges here. So, like, there's different types of animals here, but the springbuck from Africa, you know, I put a kangaroo rat from the desert here in the north, in the southwest, Gimsbuck from Africa, prairie dog from in my region here. Well, when succession is low, like like this area over here, the species that you're going to find are going to be like this. And this range right here is what we call an ecologic amplitude. So this is where that species, like the Gimsbuck or the prairie dog, can live. They do very well in that area, but you will not find, like the previous slide, you won't find prairie dogs out here. They're out in this is their place that they live. So there is this cross section of species that happens, you know, at various stages in this. Pronghorn antelope, they got a ecologic amplitude or a niche from about here all the way up to here. Sables, or well, let's take the bison. They got a range from here all the way up to here. You won't find bison here, and you won't find bison here. Humans have this really broad ecologic amplitude. We can live in a lot of different environments, from deserts to jungles. We have this capability of being very, very broad in terms of our ecologic amplitude. So, so let me go a little bit more. That that complexity above the ground also happens below the ground, and you've got all these species that interact in a way that allows conditions to happen, good or bad, in reference to our way of life. That's happening underground as it is above ground. So when I talk about what's happened with our food density, all these species are really important in terms of feeding the plant. You know, all these different organisms in here feed the plant, or they don't feed the plant. If they're not available, if they're not present, they don't give the nutrient needs for the plant that we once had in 1940. So, and this picture here just shows how many species are just in a square meter of soil, it's phenomenally amazing the amount of different types of organisms. And so the thing that's happened is that we have altered the species here through a lot of the types of management that we've done basically since World War II, the 1940s. And in the altering of those species, the loss of those species, we've lost the function of what those species did for instance, feeding the plant nutrients that that plant needs. And then the food that we eat off that plant doesn't have the copper or the calcium or the type of mixture of of health of nutrition that we once had, what they call nutrient density. So yeah, so a
A
lot of
quick
yeah,
question on that. You know how you said we need all of these and all. In one of those initial slides you had shown from bare ground it goes to weeds, and then so normally as humans, whenever there's a weed, we are trying to pull it out, or
yeah,
we are trying to put like a roundup or something like that to kill the weeds,
yeah,
because you were saying, okay, we don't want the weeds, we just want the plants. So in that process, are we trying to extinguish some of these other creatures that need to be
yeah.
a part of the soil for the growth of the plants, and for the vegetables to have all the nutrients in them?
Absolutely. That's so when we kill something here with a side, like a biocide of some sort, whether a herbicide, the pesticides, insecticides, what we do is we kill one organism, but that organism also affects all the other organisms that are at that level, that location. So when if we want to go this way successionally, more complexity, which has more stability in the environment, if we want to advance, if we poison something here, we actually start to reverse it and we go back the opposite direction. Um,
Oh.
and so and why those weeds or those things keep showing up is we kill them and we go lower succession, and then they are the things that are most adapted to be in this stage. So so we will go back into that same weed again, and if we don't allow it to continue to move to the higher level, if we keep poisoning it, we keep going backwards and setting it back. So yes, so it's all these organisms, just like here, are all related. They function together, and they're necessary in each step. So in this early part, these are the species, like these plants, these animals. Then as we move to here, we get some of the springbuck, and we get some of the and we get pronghorn, impala, kangaroo rats. So we get that mix at this stage. And then as we advance more here, we get these species and so on. And what we've done with nutrient density is we've taken a complex situation like might have been here, and we've reversed it to here, so we don't have the soil microbiology that we once had that was necessary to create that quality in the food that we have today.
So, quick question. How did we get about when initially that was a succession? That's how it was growing. What what possessed our humans to say, okay, weeds are not good, we need to kill them, we just want the actual plant growth, and started into that process about using chemicals to kill. um, what was the reasoning behind that?
Yeah, this is interesting. Is first of all, I'd say that we didn't understand soil very well, and that it's out of sight, out of mind. You don't see what's in the soil, and so we basically. And when I was in college, we learned that there's structure in the soil, which is like sand, loam, and clay. We also learned that there are nutrients in the soil like potassium, phosphorus, sulfur, um, nitrogen, that sort of thing. And we sort of treated our soils as we had those two qualities, and that was it. And so we didn't realize how important soil biology was, the microorganisms in the soil. We had no understanding of that. And and here's an interesting chart. This is from Canada, but the same exact pattern happens in the United States. That at let's see, this is the top graph right here, the top yeah, the top
In
line there.
blue.
Yes, it's the gross revenue for food that we produce. This is in Canada, but the pattern is exactly the same in the United States. I just use this one because it is so bold in terms of how it shows it. And then the green line is the net farm income. And so there is pretty much a parallel relationship between what the gross revenue was from food and what the net farmer income was from food. Well, what's happened is that, and this was about, generally, it was about 75 cents on the dollar that a farmer used to get from their food. Now that is less than 8 cents on the dollar of what a farmer gets from their food.
Wow.
Yeah, and that's why we're losing so many family farms. You know, I mean, there's a lot of policy issues that are there, but this pattern here, which there's this huge departure that happened in World War II, is having huge consequences on the viability of our farms that produce the kind of food that we hope to eat, but basically produces the food that we need to live on. And what happened here in World War II, after World War II, is that we had factories massively, mostly in the United States, because much of the rest of the world was destroyed by the wars. Um, we were producing tanks, we were producing munitions, had high petrochemical production. Major things were being produced, and all of a sudden, the market came to a crashing stop at the end of the war. There was
Mm.
no more a need for all these tanks or these munitions or petrochemical products. And so there was this change that happened right there, saying, well, what market could use that? And of course, agriculture, they use tractors. Tanks can be converted to tractors. Uh,
Oh.
and then what tractors do is they till the soil. And what that does is it oxidizes carbon in the soil. And in that process, it elevates soil bacteria, and it diminishes the fungi in the soil, mycorrhiza in the soil. And so, and the mycorrhiza and the fungi are the types of organisms that are really important for feeding the food. And so we started getting the departure, as that chart showed, 1940 to 1991, about our food quality. We got this huge, I mean, we got tanks becoming tractors, munitions became fertilizer. Fertilizer is really hard on soil organisms. And and then we started increasing pesticide use and on the croplands and the farmlands. And so those factors right there simplify the ecosystem or pushes it back. All those things, the tillage, the and the burying the ground, burying the soil surface, the fertilizers and the pesticides have had massive effect on our health, our soil nutritional qualities, and it's had a heck of an effect on the financial well-being of family
Oh.
farms and ranches across the world. And so, and about half of this cost, half of this blue, goes to tillage, to fertilizers and pesticides. And all three of those things are soil destroying things. So at the time we've been, you know, the farmer's been going bankrupt, the other thing that's been happening is we've been destroying the land with half of those costs. And so this is a huge opportunity, is to be able to start moving to an area, a way of creating healthy soil on the landscape, so that we start restoring this and bringing this back, and then bringing back the nutritional quality. And what's interesting is that the diseases that we have are pretty much related to the quality or the decreased quality of the food that we're eating in our diets and whatnot. So
Yeah.
this is a pretty significant thing that's happened right here.
Wow. Jeff, before we move into that diseases part, so just so that I can understand what you have just presented in this
Yeah,
wonderful slide, so right after the war, we said, okay, we have all this, tractor, machines and all that. Where can we put good use to it? Then they decided, okay, farming can use it. Here we thought we are trying to help, we are trying to innovate and put all this into farming. In actuality, unknowingly or knowingly, we destroyed our soil in that process
exactly.
and harmed our farmers um, in the process, and our food and our health.
Yeah, yeah, exactly. It's been, and about in here is when the green revolution happened, where we really massively started increasing that. And what that's done is that as the soil health, the biology of the soil has deteriorated, it takes more and more fertilizer, more um, pesticides, all the things that used to help stabilize the soil, the microbiology, the insects, all of these things that used to stabilize it, those things are starting to collapse and they're not able. So we have to put more pesticides out there, more fertilizer, and of course we further damage in the world what we're doing. So we're on a really bad trajectory with our food production in our world. And of course it's having the consequences on us physically in terms of disease and human health.
Wow. So why are we using so much of pesticides? Is it because we want a mass production at one time, and compared to where our fruits and vegetables used to be from years back to now, when we see it in the grocery store, most of us don't know what all takes for that fruit
Yeah,
or vegetable to grow, where all it came from, how many different stages. By
yeah,
the time you see in the store, it's huge and it's nice and shiny.
yeah.
Um, is it because of that mass production? We want to make sure that the look and it's more appetizing, so that when we look at it, we say, "Oh, what this looks good," and grab it, or it's a bigger fruit or vegetable. Is that like playing with human psychology?
Yeah, yeah, it is, isn't it? It's interesting that if that, like, I love tomatoes, but I don't like the tomatoes I get from the store, the quality. When I was younger, a tomato really had this, just luscious taste. And I worked a few years ago in Africa, and they grew tomatoes on the land without all this other stuff that we do today, and the quality was just absolutely delicious. And so what's interesting, and it is like you talk about, there's a sociological side of this. It's very complex, but I guess one thing is, first, who pays for the research to do things? Well, microorganisms in the soil don't really do that very much, but chemical companies, and fertilizer companies and tractor companies, they have the money to put into the research that goes in the universities and what gets taught in the school and the classes and whatnot. So we've actually, and I hope, it's kind of a tough word, but we've kind of brainwashed, you know, American agriculture. And there is this notion that we have to feed the world, and and that means we need to have optimal production, or maximize production on the land. And so here you can see that food, the gross revenues have gone up, and a lot of food has been produced, and it's taking more and more fertilizers, more and more chemicals to do that, because and as that's happened, the soil capabilities have diminished, and so we're destroying the soil base that used to provide this ecologic balance that was going on. And of course, we've had these consequences on the financial situation, but but there is this attitude that we've got to feed the world. How do we feed 7, 8, 10 million people? And there is an attitude also that's interesting that I work with very commonly with conventional agriculture, is that what matters most is production, not profitability. And so they could be more profitable if they took, like, those costs back. If they stop spending 50% on these things that destroy the soil, yeah, their yields might go down, but their profitability will go up, and the quality of the food that we produce is going to also go up. And so it is, it's a belief thing. And here's another part that's very interesting with it, is the peer pressure, or um, the oldest human emotion I understand is shame. And so shame is about being kicked out of the tribe, and you definitely don't want to do something that's different from your peers, the people you grew up with, the coffee shop, or going to church or whatever. You don't want to be shamed out of that group. So you're going to do what the rest of the group's going to do. And so the folks that are doing this new type of work typically are kind of isolated, and are kind of considered different and out of the norm, and you know that sort of thing. And so there's a whole sociological effect that's going on in terms of moving toward a healthier food situation that we can have in this world, which gets back to the health situation that we've our food production is not about the quality of food that we have. It's about massive production.
So
And
it's quantity over quality,
yes, yes. And
and
there,
that we are paying that,
yeah,
in terms of our health because
that's
of.
exactly right. The costs are phenomenal for having, what we put in our mouth that starts our human life. Um, the quality's gone down and is having huge effects physiologically as human beings. So yeah, so we don't even put in the whole cost of what's going on as this model. What's happening here. So yeah, you put the health costs in the world, it's absolutely stunning. So yeah.
So where do we get, if any, where can we go to get that quality fruits and vegetables that are grown the way it's supposed to be grown without all this pesticides?
Yeah. Well, one of the neat things is there are farmer markets. You were mentioning earlier when we were conversing that your son's interested in growing food. So there's a lot of food production that we can actually do, um, or is actually done, that's available, that has healthier quality types of foods that are available. And so that's an outlet right now. And of course, the market can drive that. If there's more money, more people seeking that type of food, then there's going to be the shift that's going to start happening for that kind of food. I'm trying to work, and that's why this visual right here is so important. Is I'm trying to get industrial agriculture to change to this way, so that most of the food we produce is produced in a way that also is healthy and nutritious for us. And why this curve, this chart is so important in this, is that half of that blue area that the farmer does not get anymore is going to the things that damage the soil. And
Mm.
if I can, if we can find out a way to help the farmer be financially viable and produce healthy foods, that's a huge opportunity. We still have to deal with the social pressure, the peer pressure, and that shame part. And so that's another part of what I'm doing, is helping to create conditions where it's easier, safer, better for a farmer to venture out, or working with neighbors and whatnot, and working in your community together. And so we're working on the sociological side of this thing too. Yeah.
If they do that, if they get away from this current model to
Yeah.
the actual model that you are trying to work on for them to do, will they have any financial downside? Like if they're getting reimbursement from federal government or anything, will they be losing any one of those things?
Yeah, that's a great question. It's
Because that will not, if they lose money, that's not an incentive for them to
right,
do.
right. And so that's why, so there is, because the soil has the soil complexity, the soil microbes have shifted to that lower part of that model I was looking at earlier, showing earlier. It will take time to put that back to where food nutrition was really great, where the soil microbiology was great, and they say it actually like we've seen with the pandemic, the Earth has responded pretty well to us not messing around out there. We can see, the Himalayas, for instance, in India. Um, we can, my wife's from the Philippines originally, and she can see, she saw a picture of Manila and it had blue sky, and that only happened in a month or two.
Yeah.
There's water that's cleaning up. Even parts of the ocean are cleaning up. Species are starting to venture out. They're putting warnings on going out to national parks because animals are out there now. So our presence has not been very kind to the earth, and it's part of it's just we just have a lack of awareness of the consequences of the way we live, and so if we could become more mindful of that, it'd be phenomenal. So with what I'm working to do here is to help create a condition where there will be a transition period to build the soil microbiology back. There are things we can do to do that, but I'm also thinking that um, that well, there are I'd say probably 5% of the farmers of the world and ranchers of the world are ranching in a way that creates healthy food, about 5%. And um, and they have transitioned to where they're actually economically viable, and in fact, actually, they are more resilient. They have less risk because their ecologic condition is a lot more stable now because they have very good species diversity, which helps stabilize, disease issues. Like, I understand, like in our body, we have E. coli. For most of us have that,
Yeah.
but we're not sick, and that's because we have this balance in there that's helping to manage that. But if we get that out of kilter, all of a sudden it shows up and it's a problem. And that's the same thing with the ecosystem. Our body is the ecosystem. We're very much a reflection of these things that I've been sharing with you. Um, there are folks that have transitioned now. And another interesting thing, and a fellow I'm working with in Australia has developed this amazing model of taking um, ecologic, ecologic data and economic data from conventional farming and from what we called regenerative farming. Um, and what he has found in his artificial intelligence processing of all this data is that there is less risk in this kind of agriculture, regenerative agriculture, than there is in conventional agriculture.
Mm.
What's interesting is the banking and the crop insurance world still puts their money into the conventional, giving the better rates and whatnot for conventional than for regenerative. But the data shows that it's a better risk for bankers and for crop insurance people to put their money into regenerative, lower rates for regenerative instead of lower rates for conventional. And so if we can shift that thinking, and that's what my friend's working with in Australia, is like a Yelp app on your phone. If you want to find a good restaurant to eat, you look to see who's got the most stars, the highest reviews, and that's where you go. And that's what he's developing, is with a lot of data from conventional and regenerative, showing here is actually the better financial investment as a banker or as a crop insurer. You have a higher likelihood of weathering, particularly as we're getting more instability in our climate. You have a better chance of weathering the storm than folks that are doing conventional. Like we saw in the Midwest this last when they had the floods just recently, and so many farms, millions of acres, were flooded and inundated and couldn't grow crops, whereas folks that were doing regenerative continued to grow crops out in those same areas. So
Wow.
yeah,
That's a very good work that you and your friend in Australia are trying to do.
Yeah,
Can you quickly explain to the audience how the connection between the air pollution, the water pollution, and the soil, they're all kind of connected, how that kind of flows,
yeah.
please?
I do have. Let's see. I want to go back to a couple slides back here, right here. This is one example of that, and this happens to be the discharge of sewage out of the city of Albuquerque into the Rio Grande, and so after it's been treated, um, there's been some measurements to see what's coming out of the river and or what's coming out of the effluent and what is going into the river. And so, the amount of some chemical, I'll find one like caffeine. I'll just do that because I just can say that easier. Um, so the little blue down here that you see on this chart, I don't know, can you see that okay?
Yeah,
Okay.
it's the tad
It's very
tad
small.
blue. Yeah, yeah, it's right there by
Well,
your cursor.
that's how much caffeine is in the Rio Grande as it flows down the river. What's coming out of the effluent, what's in the water coming out of Albuquerque is this high. So it's a massively different quantity of caffeine that's going into the river from that um, from the people of Albuquerque. But if you and I, I'm sure sorry it's very small print, but let me go to the next picture here. Right, there we go. So these are the compounds that I'm showing, and so there's things like antibiotics. With your medical background, you can see there's the herbicides, there's a psychoactive stimulant. These are the things that are not treated that are going into the river. Here's one that does is seizures medication, blood pressure medications, antibiotics, psychiatric drug. That's
Wow.
the stuff that's dumping into the river and having, and you can see there's very little blue here, um, which
And
means,
that's the water that's being used for
yeah,
farming.
thank you for that connection because so that treatment facility is right at the end of Albuquerque, about 10 miles downstream. The irrigation water for the valley here comes out about 10 miles downstream of this sewage plant, and sometimes in the course of the year, the water flows are very low, and sometimes the only water that's flowing down the Rio Grande is the water that comes out of the sewage plant of Albuquerque, and then that goes into where the irrigation water gets diverted and then goes down both sides of the valley here and irrigates all the cropland. So you've got all these chemicals coming down from our sewage in a city that's going into even organic farmlands, because there's farmers here that do conventional farming, chemicals and that stuff. And then there's folks that say that they're organic, but how could you be organic when you have this? This is your water that you're getting into the land, and the same thing's happening with these things are also airborne. All these a lot of these different types of chemicals are also airborne. So they basically say that there's really not very many places on Earth where you're free of different types of chemicals that we've influenced that have effect on us. And our, so it's quite challenging.
Yeah, so even if we, spend that extra money, buy organic produce, it still has all these chemicals in them. So how is this connected to our health?
Well, obviously there are consequences from those chemicals in terms of the types of cancers that show up, mutations that go on in cells, and that sort of thing. We don't really know the consequences of what all these chemicals do. We know that they will kill a certain organism or they will treat a certain issue in our bodies. We know antibiotics will kill and bacteria. Um, but they kill a lot of other bacteria too.
They kill the good bacteria too that
Yeah,
we actually need. So
exactly.
then that's how we are getting to be antibiotic resistant. When you're really, really sick, those antibiotics are not working because we have used it for so long and abused in our system.
Exactly. And this, what's going into the river here, I gave the example, it's going through the irrigation to our food system, but it's also affecting the rest of the all the organisms that live along the river. Um, it's affecting all of those organisms. And there's even in the current issue of the National Geographic, which I actually have here, it just shows it's about insects. And the caption says, "You'll miss them when they're gone. Insects are disappearing at alarming rates. That could be disastrous for the planet." They say that maybe 70% of our insects are gone, and they will not come back. They've evolved over millions of years to function and do what they do to help stabilize things, to pollinate food. Two-thirds of our food come from bees. We're getting to be conscious and aware of that, but it's absolutely remarkable what's the consequences that are having, that as we so it's we've got a climate issue that's going on. We've also got an extinction spirit issue that's going on, and these kinds of things are having just amazing ramifications. And so every day that we lose a species, that's that stability of our life that's happening, which affects all that we're talking about. So yeah, yeah,
Wow,
yeah,
that's a very good explanation in detail. Thank you. I had a question, in relation to the pandemic that has been going on, we have faced recently. Um, Humans, are disrupting the nature by interfering, such as invading in the tropical forests and other wild landscapes, which harbor many animals and plants,
yeah, yeah,
which is a part of the reason for animal-borne infectious diseases,
yeah.
right? So moving forward, what can be done for this to be a solution, so that we don't pollute the environment and respect our nature?
Yeah. Habitat loss is a huge issue on this, and so I've talked about the farm habitat, and what's going on in the soils on farmlands, and the same thing, anytime we destroy the web of life, we deteriorate it, like the insects, like the other slides I showed. The web of life is and it's like I gave the example of E. coli in our stomachs. It's there, but there's a healthy balance of other organisms in our life that keep these types of outbreaks, like E. coli outbreak in our body, from occurring. Well, same thing with the COVID-19, and other types of there's a disease that's happening right now with rabbits, wild rabbits here in the Southwest, and they're just killing them. It's an organism that's existed, just like the coronavirus has existed, but I'd say part of the problem is that we've deteriorated or lost these species that help create balance in ourselves. And then also it's the invasion of in habitat, where these organisms, where there was a separation from us and these other organisms, we just keep expanding and taking territory, and we're starting to move into these other areas that cause these serious problems that we're facing. I was talking to a friend of mine from Australia the other day, and he's leading a team to do research in Asia with COVID-19 and ecology. And this was just an observation. It's not something that they have definitive information on yet. But in Nepal, an interesting thing showing up, that down in the rice paddy where they're growing rice in the lower country, which is conventional industrial agriculture, um, the incidents of COVID-19 are just amazing. It's
Mhm.
just huge outbreaks. But when you go up on the hillsides, up going the uplands, going towards the Himalayas, um, so in those uplands where they're farming more conventionally or more traditionally, more traditionally, more species diversity and the kinds of things I've been talking about here, they're not having the same kinds of outbreaks with COVID-19 as they're having down in the rice country. And there's no knowing what that is right now. They haven't researched that yet, but it's just an interesting pattern of why is it so bad down there and why is it not so bad up on the hillsides right now. So
Yeah,
yeah, yeah,
possibly because it's an industrial area, the area is more polluted
yeah,
versus up on top
yeah,
of the mountain, the air is much more cleaner, they're breathing. So
yeah,
we just
yeah,
have to wait and see for more research to come out of that. I
yeah,
would be really curious to
yeah,
find out. This is great information, Jeff.
great.
You have really enlightened us with so much information that we did not know, because a lot of people, um, whenever we say pollution, we relate it to air pollution. We don't think so much about water and soil. So this was a very good detailed explanation. Thank you very much. And I want to ask you, if our audience want to follow you, where can they follow you?
I have a website which is aboutlistening.com, and so that's one place. They um, I also have a Facebook page that I do get a little bit. I That's a place that I do consensus work, and so usually I'm pretty neutral, but I have my biases about what we're doing on our Earth today, and so on my Facebook, if you, I've got my political sway on there, but I think we're responsible for this Earth we've created. As humans, and we can do good stuff with it or we can do bad stuff. And it's the same thing with how we treat other human beings and whatnot. Um, with my consensus work, I've seen people do pretty amazing things that just seem to be impossible and unimaginable. I worked with a group of warring ethnic groups, 7 of them in Western Africa, a number of years ago. And they had, their way of resolving conflict was violently, and they hurt each other. 2 years before I got there, 29 people got killed because some cows got on the farmland.
Mm.
And so that was their way of operating. Within 2 years of working there, violent conflict completely disappeared from those villages by learning to do things differently. But one of the workshops that I worked with, I challenged. They had 85% food insecurity in those villages, um, and I challenged them about growing more food. And I got to a point in this particular workshop where I asked them um, if they could grow 50% more food. That's a lot. And they said it was impossible, and that's what I was looking for. So I asked them to tell me why, and they said, well, they $45 a year per capita income. They don't make much money. They've got poor rains, poor soils. They even said that they were lazy. Those are the reasons why they couldn't grow more food. And after they told me the reasons, I had them look at the list, and I had them notice everything on there was a belief system. And
Mm.
because they believed $45 a year would not allow them to grow more food, they didn't grow more food. And because they believed that they got poor rains, they didn't grow more food. So when they saw that, and they saw it, it was pretty interesting how their faces lit up. And we had language differences, so I had to watch, how they're anyway. So then after that, I asked them. I said, "Well, given that it's impossible, because they just told me they couldn't do it, if it were possible for you to grow 50% more food, what would you do?" And they thought for a moment, and then all of a sudden, one idea came out, and then another idea, another idea, another idea. Pretty soon, they had a whole list of ideas of what they could do to grow more food. And in my work, I leave the puzzle unsolved, because if I solve it, the brain stops thinking about it. But if I leave them with that idea that well, what if they could grow more food, in their minds, and they'll be thinking about it at bedtime, at nighttime, and you know. Anyway, I came back 15 months later to the villages, and they were standing on the side of the road waiting for me. I mean, I flew all the way from the United States, so they were standing there a long time. But they were standing there. They had something to show me, and when I mean, before my truck even stopped, they grabbed, opened the door and grabbed my hand. And they took me out in the fields. In 15 months, they increased food production by 78%.
Wow.
See,
Wow.
that's
See what
what
you did?
humans can
Oh
do.
my God.
Yeah, that's what humans can do. It's amazing, our
Yes.
potential. Yeah,
Yeah, because we always go into our pre-programmed self, because with all these beliefs, it's that pre-programming which we need to shift from, that pre-programming to, what can be done, explore more.
yes,
So
that's
you made that possible by making them think that. Thank you.
yeah,
That was
that's right. That's
wonderful.
right. And time and again, I see that happen with groups that we work with, that can do that. And it's the same thing with this. We can have nutrient dense foods. We can have profitable farmers. We can have, good foods in our marketplaces. New Mexico, we import 95% of our food. We export 97% of our food that we produce. We don't grow our own food here, and we can, and so perhaps that'll be a gift that the pandemic gives us, is growing nutritious food again, in our own communities, and not having grocery stores that have empty shelves and whatnot. So yeah, thank you.
Yeah, that would be very good if we all can start doing that in our own communities.
Yes,
Then the food, it will be more nutritious and healthy. And also, studies show that working in the garden helps us mentally and physically.
yes,
So let's hope we can take those good lessons from here, what you have just shared with us.
yeah.
And thank you very much for joining and enlightening us with all this wonderful information. Thanks for coming and talking to
Oh,
us.
it's beautiful. I really appreciate the opportunity. I'm really glad with what you're doing. So thank you.
All
Good.
right, great. Thanks, Jeff.
Yeah.